AI, it really does feel like magic, doesn't it? You ask it some super complex question, and boom, a second later, it's writing poetry or debugging code. But here's the thing. It's not magic. It's engineering, but on a scale that is just hard to wrap your head around. Today, we are going right under the hood to see exactly how an AI brain gets built, step by step. Because that's the real question at the heart of all this, isn't it? This isn't just some clever parlor trick. It's a real process of learning and training and a whole lot of refinement. So let's break down how a machine actually goes from a totally blank slate to something you can have a conversation with. Okay, let's dive right in. Every massive construction project, and I mean every single one, starts with a blueprint. For an AI, that blueprint is all about how it's going to process the most human thing there is, language. And the very first problem to solve is a big one. How do you turn our words into something a computer can actually understand? Numbers. At its core, the machine we're building is what we call a large language model, or an LLM. And its main job is, believe it or not, deceptively simple. It just looks at a string of text and tries to predict the very next word. That's it. But when you do that one simple thing billions and billions of times over, well, that's when you start to unlock these incredible abilities. The design that really made all of this possible is a neural network architecture called the transformer. You see, before this thing came along back in 2017, AI models had a terrible memory. They'd struggle to remember the beginning of a long sentence by the time they got to the end. The transformer was the absolute game changer that unlocked this ability, letting it process huge amounts of language and understand the context between words no matter how far apart they were. So how does the transformer actually read? I mean, it can't just process letters and sentences like we do. First, the text has to be chopped up into little pieces, and we call these tokens. Now, these can be whole words, or sometimes just parts of words, and each one gets its own unique number. This whole process, called tokenization, is the essential bridge from our world of language to the AI's world of pure math. It's also why, by the way, AI can sometimes get a little weird with rare words or creative spellings. If it doesn't have a token for it, it has to kind of improvise. All right, let's keep building. We've got our blueprint. Now we need the building materials. And for an AI, those materials are data. Just colossal, staggering amounts of it. Seriously, you can think of it as the sum total of all the knowledge the AI will ever have. Its own personal, massive digital library. And this library, well, it's sourced from pretty much everywhere. It reads a huge chunk of the public internet, millions of digital books, countless scientific papers, and even massive repositories of computer code. The goal here is to give it the broadest possible understanding of how we humans use language to express ideas, facts, feelings, and logic. But listen, you can't just dump the entire internet into the AI and hope for the best. It's got to be curated and cleaned. As this pipeline shows, engineers do these crucial steps, like deduplication and filtering out low-quality stuff. But maybe the most critical step you see here is safety. They actively work to scrub harmful and toxic content to try and build a more responsible foundation from the very beginning. So, with our blueprint ready and our digital library all cleaned up and assembled, we get to the most epic part of this entire process, the pre-training. This is it. This is where the model actually reads its entire library and begins to learn. It is a phase of just pure, brute force learning that happens at a scale that is, frankly, mind-boggling. And during this phase, the model has that one job we talked about earlier. Just predict the next word or token. By doing this trillions of times, it's not simply memorizing facts. No, instead, it's learning the patterns, the grammar, the logic, the relationships between ideas. It's learning the very statistical structure of all human knowledge. And to really grasp the scale here, let's just look at the numbers. We are talking about a textbook of over 1 trillion words. That's like reading the entire English Wikipedia thousands of times over. Just let that sink in for a second. A single computer can't even begin to handle this. It takes a supercomputer, a digital brain made of thousands of these specialized processors, or GPUs, all networked together, all working in perfect harmony just to process all of this information. And the study time? We're not talking about pulling a few all-nighters. This pre-training process burns through millions of hours of raw computational time, running nonstop for weeks, sometimes even months. The amount of energy needed for just one training run can be the same as what a small town uses. So after all that pre-training, we have an incredibly knowledgeable model. It understands language, sure, but it's kind of like a brilliant librarian who just spouts random facts at you. It doesn't actually know how to answer a question or follow an instruction. So now we have to teach it to be a helpful assistant. And this slide just illustrates that transformation perfectly. On the left, you've got the raw pre-trained model, this kind of chaotic text generator. And on the right, after a process we call alignment, you have a useful assistant. Alignment is what turns the machine from a simple text predictor into a tool that can follow your instructions, be helpful, and, crucially, learn to say no to harmful requests. This final shaping is done with two really key techniques. First, by showing it thousands of high-quality examples of how to follow instructions, and second, through this fascinating process called reinforcement learning from human feedback, or RLHF. RLHF is basically a clever way to teach the AI our values. So first, human reviewers look at several different AI-generated answers to a prompt, and they rank them from best to worst. Then, a whole separate reward model learns to predict which answers the humans are going to like the most. And finally, the main AI is fine-tuned to generate responses that get the highest score from that reward model. In fact, if you've ever used a thumbs up or thumbs down button on a chatbot's answer, you've actually been a part of this exact process. We're almost there. The AI has been built, it's been educated, and it's been refined. But before it gets released into the wild, it has to pass its final exams. The challenge, though, is how do you even test a brain that knows almost everything? The testing is incredibly intense. It includes something called red teaming, where experts actively try to trick the model into generating bad outputs. It's tested for biases, and its raw knowledge is checked against standardized academic tests. This is all about finding the breaking points before the public does. And even after all of this, the work is never really done. These models still face some major challenges. They can hallucinate, which is just a fancy word for making stuff up. They can inherit and even amplify the biases from their training data. And then there's the black box problem, the fact that we don't always fully understand why it gives a specific answer. So we have successfully built a machine that can process and generate language with a stunning, almost unbelievable ability. We've given it access to the vast majority of all human knowledge. The engineering behind it is a modern marvel. But that leaves us with a final, much more profound question. We've figured out how to build the brain. The next great challenge is, how do we teach it wisdom?